In this video, I'm going to walk through the setup for these labs and how to use these labs. So first, we'll just quickly run over the setup. I've got all the instructions here on this page, but just to kind of quickly talk through it. You're going to need some kind of a Linux server or machine to run these labs on. You could also do this on Windows using WSL. I don't have experience with that. I believe you can do it on Mac too. Again, I don't have experience with that, but once you've got the environment set up, all you need to do is run this single command to install Container Lab, so it's very easy and quick. And then you're going to clone the Git repo for this workbook, and that's this repo here. It has the topology files, the config files, and things like that. You're going to install the requirements for the Python packages you need to run the Python script, which I'm going to touch on in a minute here. And then you're going to need to set up the routing for the management. So let me just talk about that quickly. It's kind of easier to show it in the topology file. So I'm using this subnet for management of the Container Lab nodes. And each node, here's R1, R2, R3, has a particular management IP in the subnet. You're free to change this if you would like to. I would recommend just leaving it, but change it if you'd like. You're gonna have to edit the topology file if you're gonna change it. But this is the only place you'll need to change it. Just to change it in the topology file, then Container Lab will start using that new subnet that you want to use for management. And then you're going to need routing to the nodes. So these are, once they're running, it's like a real node that you're going to SSH to. And in fact, Container Lab is putting that IP on FXP0 on the nodes. So if your Container Lab server is in a different subnet, you're going to need a route on your router for this subnet, this /24 via whatever your Container Lab server is. If your Container Lab server is on the same subnet as the computer that you're using to SSH to these nodes, then you might want to just set a static route on your local machine. So like here on Windows as an example from the command prompt to add a static route on the Windows machine for that subnet via your Container Lab server. So like let's say your machine is 192.168.1.10 and the Container Lab server is .253, both on the same subnet. Now your computer is going to start routing this 10.255.0/24 via the Container Lab server. If you're running Container Lab on the local machine that you're using to SSH to the nodes, you actually don't need any routing. You don't have to set up anything. And also on the Container Lab server, it will automatically route traffic in the management IP to the Container Lab nodes. You don't have to set up anything to make the Container Lab server forward traffic and act as a router in that sense. Okay, so next we need the images. We just need two images here, vJunos router and vJunos switch. These are completely free. So you'll just go to the downloads page for vJunos router. You have to change the OS to vJunos router. And I would recommend setting the version that I've got, 25.4. I mentioned that here. You can select a different version. You'll just need to edit this in the topology files. Otherwise, it's not going to find the exact image. Well, the other thing I forgot to mention is that we need the VRNet lab project. So you need to clone this. This will convert the images into containers that Container Lab can execute. So yeah, you're gonna get the QCOW2 file here, and it'll ask you to accept the license and agreements and stuff. I've already done that, so it doesn't show that here, but you'll get a download URL. You don't need any login or anything. This is all completely free. And then you just need to get the QCOW2 image into the correct VRNet lab directory. So we're doing vJunos router, so we're doing this directory in VRNet lab. And then here's the instructions if you want to use wget to do this, and just make sure to rename the file that you download to the short name, the vJunos router-version.qcow2, and then just run make. And it will make the container. Then just do the same process for vJunos switch. The URL is here. Change the version, QCOW2, and follow the same process. So that's it. Then now you'll have these two images locally in your Docker repository, and you can verify that with this command here. So now let's talk about running labs. So I'm going to start off with just the routing section. So for each section, there's like the start instructions where you're going to need to change directory into the lab directory, the Git repo that you just cloned from my Git. And then you're going to deploy the topology. So you use this command container lab deploy -t, where T stands for topology, and this is the topology file, the YAML file. This is the file I just showed you right here. So we'll just copy these. I'll get into my container lab server. And paste this in. So now these 3 nodes are starting up. They're going to take a couple minutes to start up. So while they're starting up, I'll talk through some more about how to use these labs, how these labs work. So next we've got the topology file. So this will be the topology for all the subsequent labs in this section. Generally, actually all of these labs just use this very basic 3 router topology. So you can, open this in a new tab or something while you're running labs, a second monitor, things like that. And then to access each of these nodes, you literally SSH to them as if they're a real router. So SSH on their management IP. Here's the default credentials. You also do have console access by telnetting to port 5000. And the default credentials come from the Container Lab website. So on the Container Lab website, for every single type of container, they've got a page about information about it, and the default credentials are on here too. Okay, so we're going to start a lab, and the first thing you're going to need to do is load the startup config. So this is very quick, very easy. Basically how this works is that in each directory for each topology, there's a lab configs directory, and for every node, there's the startup config file. So these all have different names for different labs. It's very useful because for some of them are like troubleshooting labs. So this way, you're not going to like copy and paste the config, because then you would see it, and then you would have kind of some clues as to what's wrong. This way, you're really starting out like you don't see the config at first, and go ahead and troubleshoot it. And sometimes I ask, don't look at the other routers, something like that. So this Python script is going to transfer the startup config. It prompts, you have to input the directory and then the config file name. We'll use that here. The nodes might not be quite started up yet. Let's take a look. So we can use docker container ls to see. And yeah, they've been up for 2 minutes and they're healthy. So I'll go ahead and run this Python script. This only takes a few seconds to execute, and this is really what makes, I hope, the labbing process for this workbook very seamless, because you just go lab by lab, and it only takes about 5 seconds to go from one lab to the next, because all you have to do is copy and paste this command to load the next startup config. And I'll walk through very quickly what the script is doing. Essentially, it's just starting a local HTTP server, and the nodes are going to load the configs over HTTP. The first thing it does is it copies the default config that Container Lab is putting on the nodes into the lab configs folder. This is so that if you're using a different management IP, it still supports that, so that I'm not overwriting my management IP when you're labbing if you change your management IP. Then it does a load override, so basically just reverts back to as it very first started up from launching the Container Lab topology. And then it transfers it does a load set on the config file name that you put in, the startup config. And we can see some of these startup configs are very basic. Like there's a basic addressing startup config that literally just puts on the IPs, and it's just in the set form. So that's all that's doing. Okay, so we've ran the script, and we've got the startup config put on there. So now we're going to SSH to R1, and the instructions are connect R1, configure 2 static routes so that R1 can ping R2's loopbacks, and you saw in the topology this is R2's loopbacks, V4 and V6 addresses on the loopback. So the V4 address via the interface address that connects R1 to R2, same thing for V6. So now the answer is hidden. Of course, you want to try to solve this yourself first. You can see that the IPs were placed on here from that script that loaded the startup config. So we'll go in here and add a static route for R2. I'll just skip v6 just to make this quick. You can look at the routing table and see that the route is in there, and all the verification you want to do. You can ping it and go, okay, I think I got this lab. Let's look at the answer. Yep, that's what I did. And then you look at the explanation. So my approach to these labs is I put an explanation that I try to be succinct, quick to read, but still pack it with information that's relevant. So here I say static routes are not configured under protocols, but they're configured under routing options. You can use show route to see all the routing tables, you should be able to ping. IPv6 is in the INET 6.0 table. We can filter the show route output to only a particular table, a particular protocol. How you don't have to use the longer prefixes like you have in iOS. So, sometimes I reference iOS because a lot of people are coming from iOS. And here's some information about the forwarding table. By default, there's no ECMP on Juno. So you can see I try to really pack a lot of information nuggets into these explanations, but still make them pretty readable, pretty quick to go from one lab to the next. So they're not really a replacement for some of the other training materials, but just a supplement to them. And then at the very end, I've got further reading sections. So this one has a lot of links. Some of them only have 2 links or something, but I link to different videos, discussions, Juniper documentation, blogs, things like that to go further in depth onto this particular topic. Then you would go through this and then you move on to the next lab. Okay, now it's a new file name. So copy this, go into container lab. I don't have to close out of R1 or anything like that. Run this command in a few seconds. It'll be done loading on all the different routers. And here we go, it's done. Now I'm ready to move on to the next lab. And we can see, like I'm still in config mode, but if I show routing options, now this is different. I've got a different static route. You can see how now R1 has a static route for 200, 200, 200, 200 via R2. Configure R2 now so it black holes this traffic, so I hope you get the flow of how these labs work. I also want to mention that this basics section can really just be done with one router for the most part. So if you're in the situation where like your local machine can handle running one vRouter but not 3, you could possibly just like maybe comment out the other 2 routers in this topology file. And then run it that way. And you should be fine to run all of these labs with just one router. Because these things are just kind of local router config things, like how candidate config works, rollbacks, configuration mode, CLI help, system settings, interface, AAA, logging, all that kind of stuff. That's all just done with one router. The other thing to be aware of with this section is that a lot of the time, I say if you made any changes, you can revert the lab. So typically you can go from lab to lab without having to run this script, because some of these things, like you're rolling back in these labs or you're just entering config modes and you're not really doing it. You're just you're setting a name server or something like that. So you're fine to just keep going on without reverting, without loading a new startup config. But go ahead if you think maybe I changed something that's going to affect this lab. Just copy, paste it into here, and in 5 seconds the config is loaded, and then you don't have to worry about that. You're starting fresh again. So lastly, I'll just talk about kind of the purpose behind this workbook. And my purpose was really more to give somebody who's like CCNP level a way to quickly get up to speed with Juniper. So it's not just to pass the JNCIA, although it's definitely going to get you in good shape to do that. But it's really more holistically to be familiar with this, these routers, and as if like your company is going to start using these and you need to get up to speed. You need to be effective with managing these routers. So there's some things that might be in here that aren't in the exam topics. For example, the switching section isn't really in the JNCIA topics, but I think it's somebody who's going to be managing Junos routers is and switches is going to want to know how this works, how to set up basic switching, how spanning tree works, how to do LACP, router on the stick with like sub interfaces. Like those are things that are very useful skills to have when you're managing Juniper equipment. So that was really more my perspective of somebody that's wants to learn how to use these. Of course, I based 90% of this from the blueprint, but I went into some things that I felt were fundamental network operating system things to know as well. And I also went further with some things like here I've got some labs with BGP. So don't feel discouraged if these are too confusing, if you don't understand it. You don't really need to know too much about BGP, but it is about applying routing policy to BGP for filtering. So maybe you're fine, even if you're not super comfortable with BGP and OSPF and stuff. But I did want to leave these in here as, this was kind of the CCNP's approach to the JNCIA. Yeah, and so I would highly recommend using all the resources that I've got listed here. I used all of these. I used this particular course instead of the shorter CCNA to JNCIA course. I created a bunch of flashcards from this. I read these 3 day 1 books. They're all very good. Created some flashcards from these as I came through something where I felt like, okay, this is something that's not intuitive. I'm going to want to create a flashcard to remember this. This old JNCIA study guide, really great. Half the book is kind of not relevant for today's JNCIA. There's multicast and BGP and MPLS and stuff, but still a great book to read. It has, sometimes I come across things where like this study guide might have a little nugget of information that's not available in the other resources. So I think they're all good to go through if you really want to become very comfortable with Juniper. And this is a great YouTube course. I watched through this twice. And some quick reference sheets. So yeah, I hope that this workbook is useful and it gives you a way to really quickly start labbing without any friction, without having to set a lot of stuff up, configure links, configure IP addresses and stuff, and it gives you a way to do like actual troubleshooting and things like that. So yeah, I hope that you find some use out of it, and of course, feel free to use this to go further. You can create your own startup config files, just locally in the directory that you've cloned. Create your own config files and put them in each one of these folders, and then replace this command here replace this field with the startup config that you want to use. So it gives you a way to expand this for yourself. So yeah, and of course, hope you can use this to create your own topologies as well. Use this as kind of a guide to create your own topologies. So yeah, I hope this is useful.